In this problem, we have a particle traveling along a path made up by two semicircles with the same radius of 8 meters. It travels from rest, initial velocity is 0, from point A, that's the start point, to point B. And during this time, its speed is increasing at a constant 2 meters per second squared. And we know that that is simply the tangential acceleration, which is a constant 2 meters per second squared, because again, tangential acceleration changes the speed while the normal acceleration changes the direction of the velocity. We need to determine how long it takes for the particle to travel from point A to point B along this curved path, as well as its magnitude of acceleration when it has reached point B. So in order to determine the magnitude of its acceleration, that is taking into consideration of both AT and AN. AT is a constant, therefore we need to find AN, which means that we need to know VB square. VB is the velocity, or actually the speed at point B, over rho. And rho is known, that's 8 meter constant. And of course, we need to know the time. So, because AT is a constant, we can apply the three kinematic equations for motion with constant acceleration. So we can have V equals to VO plus ACT, S equals to SO plus VOT plus 1/2 ACT squared. And lastly, V squared equals to VO squared plus 2AC times S minus SO. So again, we are very familiar with these three equations, and we can apply them to motion with curvilinear motion with constant tangential acceleration. So this AC right here is our AT. And this S right here is the distance along the curved path. Therefore, we can determine that at point B what S is. Because the path is made up by two semicircles with the same radius, 8 meters, S simply equals to the circumference of a full circle, which is 2 pi r, that is 2 times pi times 8, and that is 50.27 meters. And then, if we know AC and we know S, we can calculate V from this third equation. Remember, we do need to know VB in order to calculate AN. So applying the third equation here, VB squared equals to VO squared plus 2 times AT, that's our constant acceleration, times S minus SO, and SO is 0, VO is also 0, therefore VB squared simply equals to 2 times AT times S, which is 2 times 50.27. So from here we can solve for VB. VB equals to 14.18 meter per second. So VB squared equals to 201.1. We can use this directly. We can plug this directly into this equation. Therefore, AN equals to VB squared over rho, which is 201.1 divided by the constant radius of 8, that is 25.13 meter per second squared. Therefore, if we know AN, we can calculate A equals to AT squared plus AN squared. So AT is 2, so 2 squared plus 25.13 squared, square root, and that equals to 25.2 meter per second squared. So that's the second half of the question. The first half asks for how long it takes for the particle to get to point B. Well, if we know VB, which is 14.18 meter per second, then we can use this equation. So for the first equation, let me write it here, VB equals to VO plus at, again our constant acceleration times time. VO is 0, therefore 14.18, which is VB, simply equals to AT. That's 2 times T. Therefore, from here, T can be solved to be 1.09 seconds. So that answers the first half of this problem. So for this problem, it's important to recognize that along the curved path, if the tangential acceleration is a constant, then we can apply these three kinematic equations for constant acceleration. Just for reference sake, at point B, the direction of AT, the tangential acceleration, is in this direction, tangent to the path at point B. And then AN is in this direction. The normal acceleration is always perpendicular to the tangential acceleration, and it is always pointing towards the center of curvature. And the direction of velocity is also always tangent to the path.